Hi, welcome to this latest video. It's for Leetcode 200, number of islands. It is rated a medium question on Leetcode. At first glance, this is a problem that asks you to go through a grid and traverse through the grid. So when we think about grids, we should automatically now shift our thinking to thinking about graphs. So now that you know you can think about graphs, of course, think about the main techniques, breadth first search and depth first search. In this particular case, DFS is needed. So why do you use depth first search? Well, because part of what they want you to know is how many islands are formed. We'll get to that in a minute. But before we get more into DFS, I want to talk about other resources on YouTube that I think really help. One of them is Dfs Code. He is fairly recent as of the recording of this video. You can see that one of his DFS videos is from September of 2020, so pretty recent. I think he talks with a lot of clarity, and he also gives you the problems grouped together by category, and he talks about 3 or 4 problems that are DFS related. So that is a pretty good way to think about it, because you can go ahead and try the problems that he talks about. The second resource on YouTube that I think is super useful is this guy. His name is Benyam. He is currently, I think, a student at Maryland or about to graduate, and he started his own kind of interview questions website called Back-to-Back SWE. The thing is, he started with just YouTube videos, and so that he has about maybe 20 or 30 videos that I think are super good. He explains things super clearly as well, and I think that's something that's really important when you want to learn about these things. Let's remember Back-to-Back SWE on YouTube. Okay, so after saying all that, let's kind of get to it really quickly. So the problem description says that they give you a grid. This particular grid is m by n. It doesn't really matter which way is m, which way is n, but for the sake of when you do the problem, I usually do the length of the first array and the inner array to be, the length of the outer array to be m, and the length of the inner arrays to be n. And they say that when you're outside of this dimension of m times n, the rest of it is just out of bounds, right? And what does out of bounds mean? Well, right now, the number 1 right here, they count as islands. So out of bounds, they consider it to be just zeros or water, okay? So they want to take you through this particular problem by saying, okay, when you look at this, it's really easy to visualize how many ones are surrounded by zeros. And when we say how many ones, we say how many ones that are connected. So you can say here's a group of ones, right? And we're talking about connected only in cardinal directions, up, down, left, right, so not diagonal like this, okay? That doesn't work for us. So you see one group that we just circled, here's a second group, and here's a third group. So when you see this particular problem, as a human, okay, not as a computer, it's really easy to kind of visualize, okay, right now I know their number of islands is 3. And so how do you come up with that? And I think when you're looking at this problem, you have to say, well, I probably want to go through each cell in the grid one by one, like that, And if I encounter a 1, as I do here, I want to increase the count of my islands right here, right? The thing is, when you get down to the one where I'm just circling right here, how do you know that it hasn't been counted in association with the one up top? Well, the way we're going to do this is through DFS, right? Because if you use DFS, looking at this example here on the right, let's say you hit this one. Well, if you go through depth first search, imagining it as a tree or whatever, maybe you go right first. You see, oh, that's part of my island. Cool. And then you go to the other direction. So that's part of my island. And then that looks for its children and says, oh, that's part of my island. And then it'll look over here, right? Out of bounds. And it'll come back. It'll look up top. It'll see 0, come back. At bottom, see 0, come back. And it does that at the other places too. I just didn't explicitly state that. You're making that search even from the beginning when you find the 1. Okay? It's just that you find it only in one direction in this case. And so you want to use DFS so that when you start searching in a direction, right, if you find 1s, you continue to count it as one island. And the trick is that what they do is they will convert the ones that they see into 0s. So once you know this is an island, convert that to 0, convert that to 0, convert that to 0, right? When you look this way, convert that to 0. So when you do that, next time when you finish counting, because counting is going to happen like this. Here, delete that. Counting cell by cell, in 2 nested for loops will basically go like this. Shoot, loop, come back, loop, come back, loop, right? And then you're at this spot. So when you think about it like that, how do you know when you get here it hasn't been counted already? Well, you'll know that because when you originally encounter this one, and then DFS comes here, and then DFS comes here, you're going to change all these values to 0s once you count them, right? That's part of the same island. So that in the for loop, when you get back to this spot, it sees it as a 0, and you won't double count. Because the DFS here happens recursively, it's a little bit difficult to do a correct walkthrough. So we're just going to talk about this grid. And so what happens, when you loop through it the first time, right, you're going to find this cell. And this cell will look up, it'll look right, it'll look down, it'll look to the left. Here, it'll return. Here, it'll return. Here, it'll return. When it comes down here, right, it'll say, oh, I do not return right away because I see a 1. But before I do more DFS recursion, I'll convert that to a 0. And then I'll also look up, I'll look right, I'll look down, and I'll look left. Okay? And so when that step finishes, the grid actually looks like this. And then the for loop continues. It examines this grid, then it examines this grid, right? It comes to this grid here. It says, okay, I found an island, increase the count. So at this point, islands equals 2, right? And it does DFS. DFS, I'm going to look up, I'm going to look right, I'm going to look down, I'm going to look left. So I think usually we start up first. So you look up, it's going to return 0. You look to the right, what's going to happen is it says I see an island. So at this point, this is 0. Convert this to 0, and then it'll look up, it'll look right, it'll look down, and it will also look left, right? And so up here it returns, when it gets to the right, it turns that into 0, and then it looks up, looks right, looks down, looks left. I know the drawing is a little bit sloppy because recursively it's really kind of hard to do each part of the call stack. But anyway, so when you get to this island and we see that the DFS goes here and then goes here and then goes here and turns all these things into 0s, What does that look like at the end after this particular step? Well, after that particular step, you only have a single one left over. So at some point, like say you loop through this line, then you loop through this line, found those islands and flip them. Then you loop through this line, nothing. Then you get here. Okay? You get here and then you analyze this. And then it does what we talked about. It looks up, it looks right, it looks down, it looks left. Okay? And so what happens when it finishes doing that DFS? It converts that to a 0. Your grid has all zeros, and we say, oh, it does this loop, loop, loop-de-loop, comes all the way to the end, and finishes counting, right? And at this point, island is 3 in this example. So let's take a look at the code really fast. Sorry. So the code can be divided into basically the initial setup, then 2 main parts. So this is the initial setup, right? Where you define the number of islands starting at 0 because it's possible that you find nothing. And then I find it useful to consider the length and the width, so to speak, or m by n as they like to say in the problem statement, defined, right? So it's an array of arrays. So I just do the length of the first outer container array and the length of one of the inner arrays. I just picked the first one. And then you have to traverse the graph one grid at a time. One at a time. What does that mean? That means nested for loops, right? So when you're on the whiteboard, make sure when you do nested for loops, a lot of people like to do I and J. And you need to know that in this case it's a normal for loop, so you just go lesser than length, right? Sometimes you have to do lesser equal to, or you have to do lesser than some length minus 1 or something like that. But here, just your normal for loops. Second part of the code is slightly different, and we'll talk about that anyway. So you loop through the grid. And in the grid, if you encounter 1 as the value, what do? Well, first that means you found an island. And so you increment the count. And once you increment the count, what do? Well, you need to do a DFS. DFS based on where you currently are. Okay? Sorry, I wrote over that. Where you currently are, well, if we're doing nested for loop with I and J, that means you do DFS with I and J. And within DFS, you can explore the 4 directions of the current cell. So once you do that, let's take a look really quickly at the Dfs code. So this is a DFS code. And basically, because you know DFS is using recursion call stacks, you need to figure out how do you exit the recursion. This is very important. If you do not exit the recursion, you're going to get stuck in an infinite loop. Obviously, this happens a lot when you're practicing. So let's talk about what your boundaries are. Well, your boundaries are, if you're doing like m by n grid, basically means if you're falling off, like this is our grid, okay? If you're falling off to the left side, or to the right side, or to the top, or to the bottom, well, what does that mean exactly? Well, one way is if I is less than 0. In zero-indexed arrays, I less than 0 is not going to work. The other thing is m represents a length, and we know that the actual index of the length is m minus 1. So if it's greater or equal to m, we don't want that either. So that's how you know where your boundaries are. Same boundaries for j, right? That's right here you do greater or equal. And when you go out of your boundaries, you exit right here. Now, what's another way that you want to exit? If you're in bounds and you encounter a 0, right? That means it's not an island. Why continue to search? So that's when you return. Now, if you do not do any of the early termination, skip that part, then that means you found an island, right? If you do not early terminate as you search through your graph, that means you found an island. And how do you make sure you do not double count? You flip the 1 to a 0. Very important. Now we talk about DFS. How do you continue the recursion? Well, continual recursion is easy. You just keep calling the function. But what do you change? Well, you change the direction. So because we passed in I and j, you just need 4 of them if you're searching in just cardinal directions, right? I plus 1 looks up, I minus 1 looks down, j plus 1 looks to the right, j minus 1 looks to the left. And then those recursions, because you have early termination early on in the code up at the top of DFS, you don't have to worry about how they work later on, as long as you have the early termination working properly and you know where your boundaries are. And I think that's pretty much it. I think the main issue with this problem is that when you see it, you have to know, okay, this is a grid. A grid is also a graph, right? A grid is basically a graph or a tree, because trees are a subset of graphs we talked about before. So if you have a graph, what are ways to go through the graph? Well, there's BFS, there's DFS as our main friends, and in this case, DFS works the best. And so that is how you solve Leetcode 200 number of islands. And remember the others kind of resources on YouTube that you can look for that I talked about earlier. Okay, thank you.